Is it possible to evaluate this integral using a change of variable? Hi there and welcome. I'm Ferguson here. It's good to be with you. Now, what we want to do here is to take this integral, which is expressed in terms of coordinates x and y, and transform it into a new double integral expressed in terms of a new coordinate system. But how do you do that? Well, let's follow the steps I've listed down here. Step number 1 says we must first of all decide on the new coordinate system. Step number 2, once we have decided on the new coordinate system, we express our xy coordinate, the old coordinates, in terms of the new coordinates. Step number 3, we determine the limits of integration in terms of the new coordinates. Step number 4, we take our function f of xy and transform it into a new function g of uv, where u and v are the new coordinates. Step number 5, calculate the Jacobian of the transformation. I'll talk about the Jacobian in a minute. Step number 6, we set up our integral. Step number 7, finally, we evaluate our double integral. Now, let's go to step number 1. Step number 1 says, decide on the new coordinate system. Now, let's go to our region of integration, because what happens here is that our f of x, the function, is being integrated over the region R. Now, over here, it says R is such that x squared plus y squared is equal to a squared. Now, this defines a circle of radius a centered at the origin. So our region R is a region which is bounded by a circle of radius a centered at the origin. I've drawn here a circle centered at the origin, and it's of radius a. That defines our region of integration. Now, immediately, this suggests to us a transformation from rectangular coordinates xy to polar coordinates r theta. So we are going to have a transformation from xy coordinates, which are rectangular coordinates, to polar coordinates r theta. Okay, now let's go to step number 2. Now that we have decided, we're going to convert the rectangular coordinates into polar coordinates. Let's go to step number 2, where we need to express our x and y in terms of the new coordinates. Now, what is x in terms of polar coordinates? X, we know it's equal to r cosine of theta in polar coordinates. Similarly, y is equal to r sine of theta in polar coordinates. So we have done our step number 3. X and y are now expressed in terms of the new coordinates r and theta. Let's determine the limits of integration in terms of our r and our theta. We know that this is a circle of radius a, so our r ranges from 0 up to a. So we have 0 is less than r, which is less than a. What about our theta? Our theta ranges from 0 all the way up to 2 pi. So we have 0 is less than theta, which is less than 2 pi. So these are our limits of integration. Step number 4. Let's convert our function f of xy into a new function g of r theta. Of course, now our new coordinates are not u and v, but they are r theta, because we are changing to polar coordinates. Now, when we look here, the term inside our square root sign is an x squared plus y squared term. Now, x squared plus y squared is in polar coordinates r squared. So it's like a plus the square root of r squared, which is equal to a plus r. If you are in doubt, let's just show you here. X squared plus y squared is equal to, remember, our relationship here is x is equal to r cosine of theta, which is r squared cos squared theta, plus r squared sine squared theta. And from trigonometry, when we take out our r, that becomes r squared brackets cos squared theta plus sine squared theta, which is equal to 1, because r sine squared theta plus cosine squared theta is equal to 1. So that simply becomes r squared. So our g of r theta becomes a here, plus what's inside the square root sign is r squared, so it simply becomes r. So g of r theta, I keep on saying g of r theta is equal to a plus r. So here we're going to replace it with this. Okay? Right. What about step number 5, where we need to calculate our Jacobian? Well, the Jacobian of the transformation J is given by partial xy over partial r theta. And this is a determinant which is equal to partial x over partial r. Sorry about that. This is partial x, partial r, and partial x over partial theta. Over here, it's partial y over partial r, partial y over partial theta. Just let me repeat because I messed up things down here. This is partial x over partial r, partial x over partial theta, partial y over partial r, partial y over partial theta. And again, this is a determinant. Now, what is partial x, partial r? X is equal to r cosine of theta. So partial x over partial r is equal to cosine of theta. What is partial x over partial theta? It is equal to minus r sine of theta. Over here, what is partial y over partial r? It's equal to sine of theta. What is partial y over partial theta? It's equal to r cosine of theta. Now, let's evaluate the determinant. Remember, the determinant is product of this minus product of that, which is equal to r cos squared theta, r cos squared theta, plus r sine squared theta. Read it carefully. Cos times cos is cos squared theta multiplied by this r. It becomes r cos squared theta. Here it becomes r sine of theta. It's a plus here because we are subtracting this, and this is a minus. So again, from trigonometry, this just gives us our r. So our j is equal to r. Our Jacobian of the transformation is r. We are going now to step number 6. We want to set up the integral. Now, when you have a function f of xy, a double integral in terms of f of xy, and you want to transform it into another double integral in terms of new coordinates r theta, we have the double integral over r of f of xy with respect to the x dy will be equal to a double integral of r prime. The region over which you are integrating is also transformed from r to r prime. And our f of x now becomes g of r theta, the new coordinates, and our dx dy is now replaced by partial xy over partial r theta, our Jacobian, of course, dr d theta. So our dx dy is replaced by dr d theta multiplied by the Jacobian. Now, let's put in the values. So our integral, we can write now that our integral, our double integral with respect to r over r of a plus the root of x squared plus y squared dx dy now becomes a double integral over r prime of our g of r theta becomes a plus r, and remember our dx dy becomes the Jacobian dr d theta, which is the Jacobian, of course, is r dr d theta. Let's look at it again. Our region r over which we are integrating is transformed to r prime. Our function f of xy becomes g of r theta, which is a plus r, and of course our dx dy is replaced by this term here. Now let's remember that we have already calculated our limits of integration. Our r ranges from 0 up to a here, and our theta ranges from 0 up to 2 pi. So we can now put in the limits of integration and say theta ranges from 0 to 2 pi. R ranges from 0 to a. And our g of u, of course, is a plus r multiplied by our Jacobian r dr d theta. Integrating first, let's simplify this expression. So we have 0 to 2 pi, from 0 to a of ar plus r squared, or with respect to r d theta. This, of course, can be simplified to from 0 to 2 pi. When we now integrate with respect to our dr, we have half ar squared plus 1 over 3 r cubed from 0 up to a d theta. I'm rather writing awkwardly there. Let me come over here. So here we are now. We have integrated with respect to r, and we need to evaluate from 0 up to a. That becomes from 0 up to 2 pi of a half a cubed, because our r squared becomes an a times an a, that becomes an a cubed, plus 1 over 3 a cubed, or with respect to d theta. This, of course, can be simplified to, we have a common denominator 6 there. 2 into 6 is 3 here. 3 into 6 is 2 there. So that becomes from 0 up to 2 pi of 5a cubed over 3 d theta. When we multiply by 2 pi, this simplifies to 10 pi a cubed over what? No, sorry, I beg your pardon. This is 6 there. Yes, common denominator 6. Sorry, I made a mistake there. So this is 5a cubed over 6. This over 6, and that simplifies to 5 pi a cubed over 3. That's the value of our double integral. Notice here, we could have integrated this double integral directly without a change of variable, but if you try that, you will end up with a rather ugly integral, which of course is possible, but it's difficult. So a change of variable does in fact simplify things. If you are new to the channel, please do subscribe and press the like button. That's what keeps the channel moving. Till we see you in our next video. Take care and bye-bye.